matchmaking in Halo 3. That was written in F#. That was used by Bungie. 343 used F# again in their back-end services for Halo 4. GameSys, mobile game company in London, use F# for their back-end services. But you'll kind of notice a pattern there. They're all tending to use it for their back-end services. Why not bring it down to the client side? What features of F# make it a great language for game development? Well, it's influenced by OCaml. So we end up getting this really nicely modelled game domain in it. We've got static typing. My errors get caught by my compiler rather than by my users. It's got a great community, which really helps with picking up the language and getting more people involved with it. It's functional, otherwise I wouldn't be here today. And it runs everywhere. And that runs everywhere is a big thing. So there's an open source implementation of the .NET framework called Mono. And thanks to the Mono project, it runs on lots of devices. So we've got Android, iOS, PlayStation support is a big one that a lot of people don't realise. We've also got support for Windows devices, so Windows 8, Windows Phone, all those kind of things. And we've also got things like Linux support, we've got Wii support in there as well. And because it's all .NET framework code, we can use libraries and frameworks that run on .NET. One example of this is Monogame. Monogame is an open source implementation of XNA. So XNA was a framework made by Microsoft to allow people to run games on the Xbox 360, and it was really popular. And Monogame abstracts away all of our rendering and all of the messy stuff that you have to do with a graphics card to make stuff appear on screen. And so we end up with a single code base, one code base to rule them all. And there's people who've been getting sort of 95, 96, 97% code reuse across their entire game engine. So they've got games running on iOS, on Android, on PlayStation devices, and they're all using the exact same code base. But why would you use them together at all? Why would you want to use functional programming with games? Well, I'm not the only person who thinks they're a great fit. This guy, who sometimes makes games, I guess, I've heard they're quite popular. If you've not seen it, at his QuakeCon keynote in 2013, he spent about 30 minutes going in detail about how Haskell has been great for him as he was rewriting Quake as a project to learn Haskell. And he was saying, it's this really natural fit. And if we take a look, we've just got this sort of nice time series update. We've got a player, we do some stuff to that player, and we just get a new player. And we do this just 60 times per second. People tell us, oh, functional language is great for doing time series data analytics or whatever. Well, if it's great for that, surely it's great for doing the generation of the data as well. Now, because we've just got this chain as well, we can choose at any stage in that chain to just drop stuff, get rid of it. If we get rid of it, we can quickly prototype, come up with new plans, come up with new ideas, see what else we can do with the language, and what else we can do within our game that makes it more enjoyable to program in, and generally gives us a better experience whilst developing. Now, if you remember my comment about the static type system in F#, when I say static, I mean really static. We can have units of measure, which is really useful in games where you can have leagues, fathoms, meters, centimeters, feet, inches, all those in the high level, and then you get down to your low level where you've got like 5 or 6 different stages of pixels on a screen. And if I can't guarantee what that's going to be rendering to at any stage, it's going to mean that my code could potentially include bugs. which users don't actually like that much, turns out. Now, the other great thing is functional languages tend to be a lot smaller. So my first foray into F# for games was basically rewriting a platform game that I'd written at a game jam. You know, it was a team of 5 people, all writing C#. You know, all had the same list of features. The C# version was 1,000 lines of code, and it took 5 people a day to write. The F# version took 1 person 4 hours in an afternoon to write, and then a bit of time to clean up afterwards. And once you've got that less code in there to worry about, it means that it's easier to maintain as well. Going forwards, you know, you can start to think about, well, actually, it'd be really cool if this dragon had a giant rocket launcher on his back, which would, you know, do all this crazy stuff, and you can start to really get into your code base quicker and easier. When you then combine this with a nice interactive environment to work in, you know, whilst it might seem like a little tiny thing, so if you've got F#, you've got F# interactive, etc. These are things which are only just coming into languages like C#, despite it being something that you'd really expect. If you've ever made a game or anything, and you've got some level defined somewhere, and you go and play it, and you say, alright, this looks good, and then you try and jump somewhere, and it turns out you can't get to the platform. So you quit your game, you go all the way back, change your level definition, reload it all, and you still didn't make it. So you go all the way back, and repeat, and repeat, and repeat. And it ends up being soul-destroying work because you know that it's the silliest little thing to fix. Yet, it's taking so long to do it. And here's the thing about games. When you're dealing with some company code base, you're given a list of requirements of what your code is going to be doing. It's going to be, it needs to authenticate my user or whatever, it needs to go and fetch all the latest stock prices. With games, you've got one requirement, and one requirement only. And you can't write tests for it. It's to see whether what you're doing is fun. Now, if any of you have got a test, which I can write, that tells me if something is fun, please tell me. It will save a lot of hassle. So the way you typically approach something like this is you go out and you choose to write your game in some scripting language. So you probably choose something like Lua, or Ruby, or Python, or JavaScript, or whatever else you might like to use. And you go and spend some time, probably at a game jam somewhere with a couple of friends, you try and make this game, and you make this mechanic, and you think it was really good. So what you do is you go out to somebody with a source of money, some publisher somewhere, and you'd say to them, I've got this great idea for a game, and I think you'd be definitely interested in hearing more about it. So you explain some more to them about what it does, and how you play it, and what's the unique selling point for it. And they get really interested in it, and they like it more and more, and they say, alright, we'll give you some money to make it. But you've got to scrap this, and scrap this, and add this, this, and this. And so what you then do is you spend the next 3 to 6 months choosing to go back over your game and end up having to rewrite it in a completely different language, which potentially runs on iOS, on Android, or whatever. And you might potentially have to be rewriting that in several different languages. You know, I might have to write it in Objective-C on iOS, Java on Android. And it's just a lot of hassle to be able to get, you know, this code base running across running across all the platforms that I want to target. And so once you start to combine all of these features, you know, we can start to do things like take the no stars which we'd have in our, or no stars that our users would rate us if our applications kept crashing because we've got silly little bugs because we're rendering in the wrong place because of where we're rendering to based on units of measure, that kind of thing. or whether we've got no stars because it's the most boring game you will ever play. And you know, we can gradually start to make our game better and better and better, and hopefully we can start to do things like manage to reach our 5-star goal and get that coveted top spot on the App Store. But you know, games aren't just about the user. It's all about having fun for developers ourselves. You know, most game developers are doing game development because they're not getting the chance to do this kind of thing at work, or you know, they're doing it as a side project or doing it to learn a new language. And with features like those that we've seen in F#, you can really start to make better games, make more enjoyable games, but also have more fun doing it. And when we combine features like F#'s type providers, we can actually start playing games directly within type providers. You know, so we've got implementations of Minesweeper running directly within your Visual Studio IntelliSense. You can play games like 2048. If you play 2048, you'll know it's quite addictive, but your boss probably doesn't like it when you're playing it at work. Play it in Visual Studio IntelliSense. He'll never know. And you know, this all brings the point that, well, development is meant to be fun, right? We all spend time doing it every day, so let's make it fun. Do the fun things. You know, if we've got these tools available, do them the fun way. There's no need to do them the boring and dull way. So, the games that we can make, you know, a lot of people sort of ask me, well, this is all written in a functional language. And that means lots of memory allocations, doesn't it? And it means it's going to run horrendously slow, and it's going to get like 5 frames per second on my iPhone. Yet, it doesn't. You know, this isn't like some mainframe in the 1970s that we're running our games on. This is something that's pretty much a supercomputer that you've got in your pocket. Argue away the layers of abstraction causes performance. It's not that much of a performance hit. Most games that I've seen, you get maybe a 10% loss in frame rate, which is negligible to say the least, because that's about 1.5 milliseconds per frame. It's not that much, and think about all the hassle you'll save and all the fun you'll have doing it then. So, whilst it's not a complete game right now, I just thought I'd show a quick demo as to what's sort of achievable. This was something which was written in about, I'd say about 6 hours or so. You know, it's not going to be something which is going to wow the world, and we're going to be able to say, this is going to be #1 on the App Store. But we've got, you know, a sort of basis of, here's what we're getting. We're getting 60 frames per second. We're getting all the performance that we'd ever want out of our game. And it's running and it's rendering constantly. Forgive the programmer artwork, please. Please forgive the programmer artwork when it loads. You know, here's the rendering being done. It's doing it more than 60 times per second right now. I think that's being updated about 450 last time I checked, which was about 20 minutes before the start of my talk. So hopefully it's not degraded since then. But as you can see, you know, to do something like this, which is sort of the basis of a full sort of strategy game where we can have loads of different players playing at once, etc., we can start to get into code bases which are like 500 lines, and yet they're doing a lot more. To get to that stage in a C# project, it got to about 1,500 lines of code, and it nearly cost me my sanity. So it's kind of, I do value my sanity quite a bit. So I decided to pursue with the F# version instead of the C# version. So are there any questions?
We have 1 minute or 2? All right, thank you. if there are not, then perhaps we should.
If there are not, then do some more demos.
You do.
Update.
Then why don't you take the rest of your time going through
Some more demos.
All right.
So let me just do this whilst we get some demos.
Could I just have one question then?
All right.
Your bosses, I mean, have you any trouble with the people that are paying you with using your shop?
No, it doesn't mind. It doesn't mind at all. In fact, he's standing right here. Yeah, Anthony, you're doing a great job using the shop. But I mean, for me, this is still just a side project. You know, I'm still mainly a student at university, so that's my main focus right now. Hopefully, the game that you've just seen, whilst very small, will hopefully one day become something. And when I say one day, probably forecast to be about 2 weeks' time right now. So.
All right. John?
Can you just explain the game a little bit more? I mean, you said it was updating 450 times a second, but nothing was happening.
Yeah, so with games and rendering and that kind of thing, we do have to continually update and continually render, even if you're not doing anything on screen at all. So in that case, whilst there was still stuff going on under the hood, you know, it was still sending messages between all the units and asking for state and all that kind of thing. As there was no movement going on, it's not actually rendering and updating. So hopefully, in a minute when I've got another game open, you should be able to see what I mean. So, this one's a decent one.
You're not on the.
Yeah. So remember what I said about this whole REPL thing? Being able to just write a game, hack up an idea, and start to build it up. Here I've just got a little bit of a script which is just going to run through and start my game up, and I'm just going to start to modify my game world directly. Right, so I've got my game running here, and I've got my F# interactive window opening here. So what I can start to do is I can do things like, let's add more players into the world. And if we go over here, we'll see we've got a new player appeared. And we can start to render more. And, you know, because this is a full interactive window that we've got running, we can start to actually run through and do proper expressions and run actual code. And so we can start to get games running. And now if I just open up another example. Where we'll see some actual rendering going on and hopefully some movement and that kind of thing. You'll be able to see that, you know, there's a lot going on under the hood with most of these games. They look simple things, and the key point is that, well, at the end of the day, all of these are still actually purely, or there's no mutability involved in them under the hood, apart from in the REPL example there. You know, this is taking a completely mutable C# design code base and then starting to run it on our purely immutable F# solution. You know, that's updating. It's just a simple little example, but that's updating sort of 450, 500 times every second, and the C# version runs at the same speed. You know, garbage collectors have been optimized a lot so that they can handle these kind of situations of having objects that live for a frame equivalent, really, 16 milliseconds or so. So they actually perform pretty well.
Oh, we lost.